All right, I'm guessing, ladies and gentlemen, that if we would have done our entrance slip yesterday after the post lab, that you might have had something a little bit different for the first question here, okay? Because we actually brought into the equation the deviation. So when we're talking about this entrance slip over accuracy and precision, the first thing that we stated was, or that you were asked, are the values that Heather and Jason determined precise? Okay, I guess we can go ahead and read the question. Heather and Jason determined the density of a liquid 3 different times. The values they determined were 2.84 grams per cubic centimeter, 2.85 grams per cubic centimeter, and 2.80 grams per cubic centimeter. The accepted value is known to be 2.40 grams per cubic centimeter. Now, were Heather and Jason precise? Give proof. Well, the easiest way to explain this is using the deviation. So, deviation is the measured value minus the average value, the absolute value of that. So we should never get a negative number. So as I do this, I need to come up and make and I just put this little chart in here. You don't necessarily need a chart, but on the first one, my measurement was 2.84 grams per cubic centimeter. My second one was 2.85 grams per cubic centimeter. And my third one was 2.80 grams per cubic centimeter. So when I go through and I added all of those up, I got a value of 8.49. I divided that by 3 to get my average to be 2.83 grams per cubic centimeter. So that's my average. As I take the deviation, I can see that this is 0.01. Is that, Nick, the correct amount of sig figs? Got a couple of Nicks in here. Yes, it is the correct number of sig figs. Once again, all of my values over here are in the 10th, the 100th place. So when I'm adding and subtracting, I need to have it at the 100th. Okay? 2.85 minus 2.83 is going to give me 0.02 for my deviation there. 2.80 minus 2.83 is going to give me a negative 0.03, but it says the absolute value. Okay? So I do that. When I add all those together, 0.06 is my value. And when I divide 0.06 by 3, I get an average deviation of 0.02. So my density is going to be 2.83 grams per cubic centimeter plus or minus 0.02. Now, based on the values I am looking at, what is, okay, the question that was actually asked was, are they precise? So my answer would be yes, they are precise because my deviation was 0.02, which is very close to my values, the average. Yeah. Usually, the question is, what would not be precise? It's probably depending on what you're collecting, okay? when we talked about the values, if I would have got two of these values, okay, if I would have got two of these values, like 2.84 and 2.85 up here, and then my third value was 2.40, then that deviation is going to go up a bunch, okay? So it's going to be depending on the kind of measurements you're taking, okay? Calculate the percent error using the average of their measurements. Hopefully, percent error is getting easier for us folks, but I still see some people flopping, okay? I see people flopping the experimental right here and the theoretical values, all right? Now, I need to find out what is experimental, what we did there. So this is the average that we did. So I'm going to take the average that I just calculated, 2.83, and I'm going to subtract from that the theoretical value, okay, which is right here, the accepted value. So that is 2.40. And I'm going to absolute value that. Then when I divide it out, I'm going to have a 2.40, since that's my theoretical, and then I'm going to multiply by 100. Now, as I take the 2.83 minus 2.40, that's going to give me a 2.83. I'm just going to show you 2.40. It's going to give me 4 point. Sig fig should be right there. So this value then is going to give me 0.43. Now I'm going to take that 0.43. I'm going to take that 0.43 and I'm going to divide it by 200 or 2.40. Then multiply that by 100, and it's going to give me a value with two sig figs because of the 0.43 right there. So my value is 18% for my error. The third and the final question was, are the values accurate? Explain and give proof. Now, are the values accurate? No. No, those values are not accurate. Why are they not accurate? Olivia, what do you think? They're all off by at least 0.4. Well, we need to start, ladies and gentlemen, associating accuracy with what? What calculation's accuracy? Percent error, okay? What did I tell you your percent error should be, Olivia? That's what it was. What should it be on an accurate experiment? 5% or less. Is this 5% or less? No. So I would say no. My proof was my percent error was 18%, which is much greater than 5%. Okay, so are the values accurate? No, they are not. My percent, and why are they not accurate? I gave proof right there based on my percent error that I calculated on the previous problem. Any questions on that? Sweet. Go ahead and pass that up.